Okay, we're in section 37, and this is going to be an application of integration, part 1. And that application is going to be the area between curves. This largely depends on your ability, 1, to know pre-calculus, that's how to graph, 2, visualize Riemann sums, and 3, set up an integral that represented by those Riemann sums, and then do the integrations. Sometimes the integrations will be incredibly easy to do, where the answers are very nice. Sometimes the integrations will kind of be nasty, but we'll go through that. Now, when I go through that, I'll talk about using technology, but for the most part, I wouldn't worry about technology at this point, because on exams, it's not going to come up. Where's technology going to come up? In the real world. You have to be able to do it in the real world. But again, we'll go through it. I'll go to the whiteboard. And then after we do the lecture part, we'll do more examples and try to hammer this across. After we do examples, I know this is new material for most students. What you're going to be doing is you're going to be doing homework. All right. It's important you start to reinforce what you're learning by study. Let me go back to the whiteboard. Give me a moment to do so. All right, we're there. Okay, so I'll read it to you, and it says over here, this is going to be area between curves. I'm seeing this guy over here. I see that shaded region. We've been doing this for some time now. I do not know the formula for that shaded region. It looks pretty odd to me. I mean, it's not like a square, a rectangle, a circle. You know, it's things I don't know about. However, I want to point out what you could do is you could compute the size of these little tiny squares over here and approximate the area. That's not a bad idea. You could do that. But the deal about this one over here is that we need to have a better procedure than approximations. All right. So what we're going to do is we're going to look at the curve carefully, and I want to go through that one step at a time. They said the curves are going to be as follows. The first curve, looking at it, is going to be the sine, minus sine of x. Right now, which one of those two curves is that? Well, I'm kind of looking at it, and I got to, you know, certainly you need to know math 120 to know that. This guy over here is this thing here. I'm looking at the picture. All right. So this thing is f of x equals minus sine of x. Let me do the next guy. What's the next guy going to be? It's going to be this guy. Also incredibly easy to graph in. What are you going to do? You're going to graph that now. So what's going to look like? That's going to look like this guy over here. Now, someone would say, my graphs are not very accurate. They don't have to be. They have to represent what you're looking at. And that's what I'm looking at. All right. You know what? I made a mistake in the that red curve. I got to correct it now. Sorry about that. Okay. Then they say from 0 to pi. Well, let me put that down. This is 0. What's the point there? 0, 0. And this is the point pi. Pi also evaluates as 0. That's where they two intersect. So your first thing is to visualize what the area is. And what I mean by that is you're going to shade the area in between those two curves. All right. And we've been doing this for some time now. So let me just, point out what I would do over here if I were doing that. So it's already done for you. Well, we want you to do it. We're giving you good pictures for a reason. We'd like you to look at them and make sense out of them. All right. And again, as we go through the problem sets, this will be the first thing I'm doing. I'll be drawing the curves. Then I'll be shading in the region they're talking about. And next thing I got to do, I have to visualize a Riemann sum. And the way I'm going to do that is I'm going to draw a picture of a rectangle like this. I'm going to put that rectangle in for you. Now, someone says, why do you put the rectangle there? You could do it otherwise. I mean, you could do it really any way you like. But when I'm doing this over here, I start to realize this reminds me of what we've done with Riemann sums. So what would I do? I would need to know the area of that rectangle. Well, I think I know it. The width of it, I'll say dx, and the height of it is going to be upper minus lower. This is why the graph's important. What's the upper curve? The upper curve is actually, this is the upper part, is going to be minus sine x. The lower curve, I forgot to label the lower curve. Let me put that down for you. The lower curve, this blue curve, is going to be g of x equal minus 2 sine x. So the lower curve, right, the lower curve, this thing over here, is going to be minus 2 sine x. What's the height going to be? Upper minus lower. So it's going to be minus sine x minus a minus 2, which is plus 2 sine x. So I know the area of the rectangle. And what's it going to be? It's going to be this over here, which is sine x. And we've been doing Riemann sums for a long time. One of the reasons we spend a lot of time with Riemann sums, once you understand a Riemann sum, you could set up integrals pretty easily. All right. What's the width of that rectangle? Dx. What are you going to do? You are going to add the rectangles together by using integration from x equals 0 up to x equals pi. We're moving along the x-axis. X equals 0 up to 2 pi. All right, let's talk about it. I need to visualize. I've done that. I visualized my area. I need to get that Riemann sum set up. What am I looking at? We're looking at integration, looking at tiny little rectangles, and I set that up. I got my integral set up. Now I'm going to do now, see if I can do the integration. This is recognizable to me. And what I mean by that is, well, the antiderivative of sine is minus cosine. Now you can put the c in if you want, but it's going to drop off because it's a definite integral. And I'm going to evaluate that from 0 to 2 pi. What do you get over here? Oh boy, I got to do the work, don't I? Minus, let me see if I did that right. Not 2 pi. I'm sorry. I made a mistake. I said 2 pi. It's pi. It's right over here. Someone says, how did you know you made a mistake? I was not getting a number that could have represented by the area. The area would be positive, and this would not be the case. Let me just put this down for you. Got to get my eraser out, and I'm glad I looked at that. That's pi. I'm going to correct myself. So it's going to be minus the cosine of pi, minus a minus, which is plus cosine of 0. Yes, you need to do the arithmetic. What do you get? Well, minus a minus 1, which is 1, plus 1, which is 2. All right, let's go look at the key. And what am I seeing? Answers 2. Let me point out, if you were to count up all the little tiny space over here, you'd approximately get 2 if you did that. All right, integrations are far easier to deal with. All right, let's go to the next one. And when I do this over here, I'll look at their better picture. There's no doubt about it. What I'm going to say is you should be able to graph these curves out. All right, you should be able to graph those two curves out. Now, what's the easiest curve to graph out? I'm going to say x squared is really easy to graph out. And what does it look like? I'm going to say something like this. Again, I'm not saying this is the best picture in the world. All right, I know it goes on forever. And then x cubed, I should know x cubed. And someone says, I know x cubed looks like sort of like this. I know the curves match up there. And then where else would they match up at 1? All right. Now, what I know about the cube curve, I know it grows much faster than the x squared term once you exceed the 1. And it goes down like this. And it's below this thing over here. I know it's tough. Look at a better picture later. All right, I'm going to put my curves in with different colors now. That's the cubic. And this is the parabola. This is a point of intersection over here. And again, I'm not saying my pictures are great. Just saying it's enough for me to understand what they want. So they want to compute the area between those two curves. Well, I have to know between from where to where. They say from -1 up to 2. So I'm going to say -1's over here. And then up to 2. I'm going to say 2's over here somewhere. No, it's not drawn to scale. Let me kind of extend this guy over here. And you know what I'm gonna do? I'm gonna start the shade. Let me blow this up a little tiny bit. I'm gonna start the shade. Is this region in here? It's this region over here. And it's this region over here. All right. We have 3 distinct regions, and I got to do one at a time now. All right. The first region I'm going to do this region over here. So I'm looking at this rectangle. Looking at that rectangle there. So then the question becomes is, where does the integration for that region, this is our first region here, where does it start? At -1, and that region stops at 0, and we're moving along the x-axis. What's the height of that? Upper is x squared minus the lower is x cubed. Like what I'm saying over here, upper, lower. Let's do the next region. This is going to be region 2 now. Plus, it starts at 0, it stops at 1. We're moving along the x-axis. Upper minus lower. The upper curve is the quadratic. The lower curve is the cubic. Plus, we're going to do the third region now. This is the third region over here. Where does it start? It starts, whoops, sorry about that. It starts at 1 and it stops at 2. We're going along the x-axis. What's the upper now? It's the cubic. What's the lower? The quadratic. Okay, let's talk about what we just did. We visualized. We're looking for that Riemann sum. We're setting up an integral. Now I get to integrate. All right, let's integrate. One at a time. We'll get an answer at the end, and the answer might be difficult. So what do you get over here? The first integration, x cubed over 3 minus x4 over 4, limit integration -1 to 0, plus next integration, x cubed over 3 minus x4 over 4, 0 to 1. Next integration, x4 over 4 minus x cubed over 3, limit integration 1 to 2. Well, I'm going to do each one separately. Again, if a lot of students have trouble with the arithmetic, that's okay. Make sure you know you're doing steps. Make sure you understand what those steps are. Graphing, visualizing, setting up integrals, doing the integration, and doing the arithmetic. Arithmetic's really the last thing I have to do. So let's put this down. That would be 0. That's the upper limit, minus the lower limit. Let me see if I can put that down. That would be -1/3, -1/4. We'll do the arithmetic later. Plus, this would be 1/3, -1/4. That's upper, right? Now I'm going to do lower. Minus, that would be 0, 0. I'll just put 0 there. So this is the first integration. That's the second one. Let's do the third one. What do you get over there? A little more complicated, but I'll do it for you. 2 to the 4th power is 2 times 2 is 4, 8 16/4. Minus 8/3. Minus, well, I got some troubles here. I'm going to put it down, 1/4, and that's -1/3. Now, sure, I realize sometimes I don't think I could do the arithmetic. It's too difficult. You really shouldn't say that. You should say, I'm going to try. So what I want to do is I just want to outline for you that I like to do things one at a time. And certainly when I do that over there, I'm looking at thirds. Let me put this over here. I'm looking at this. I'm looking at this. I'm looking at this. And I'm looking at this. And you're going to see me do that. All right. Now, so what do you mean you're going to do that? I'm actually going to do thirds. So 1/3, 2/3, minus 6/3, minus 5/3. Let me try that again. 1/3, 2/3, minus 6/3, minus 5/3. I think I did okay. We have an answer key to look at though. Now I'm going to do my quarters. Yep, I make mistakes sometimes. Let's see if we can do that. 1/4 minus 1/4, no quarters. 16 quarters minus 1/4 is 15 quarters. Oops, let's go back to that. Let me get it again. 1/4 minus 1/4, no quarters. 16 quarters minus 1/4, 15 quarters. Common denominator, 12. Minus 20. It's doing grade school arithmetic. Plus 45, which can be 25 twelfths. Let me repeat this. This carries the least amount of weight in the problem, the arithmetic. What carries the most weight? Being able to set up the integration. That carries all the weight. If you're having trouble with arithmetic, I do point out you should learn arithmetic, but people do make mistakes. We give you a key to hone your skills, and it's right over here. I want to point out, some people say, oh, you wrote something down different. The only thing I did different was I noticed that these two integrations can be written as one, and that's right over here. It can be written as one. The other thing I wrote down, this one over here, I'm going to be honest with you, this is not a good idea because it's really tough to integrate an absolute value function. But that is true. You could write the absolute value down and actually do the integration and you get the same answer. All right, let's go to the next page. Next page is going to be, they give you a better picture. Someone says, why do you give me better pictures? We would like you to look at those pictures. And I want to point out, just outline for you. This is and again, you study things and that's the whole point of it. This is the square root function. Sorry about that. All confusing, right? The blue is square root function. Let me get my eraser because I went the wrong direction there. And let's do the cubic. I'll do that in red for you. The points of intersection down for you. We did this before. This is 1, 1. This is the point 0, 0. What I do, I shaded it in from -1 up to 2. This is 2. Let me continue with the red line over there. What I do, I shade it next. I'm hoping you remember me doing that. And that's something like this over here. I'm hoping you remember I did that. Now someone says this graph is much better than the other one. You're not kidding, a machine did it. This gets shaded in over here, and this gets shaded in over here. All right, let's talk about the curves. The blue curve is above the red curve from -1 up to 1, and then the red curve is above the blue curve there on out. Okay, so let's take a look at the next one. And my goal over here is that this one's more difficult, and you're going to see that. And what I mean by seeing things, you're going to see things that aren't so simple to do. All right. Now, granted, I don't think it'll be a good exam question, but again, it's a good opportunity to talk about it. So I'm going to say over there, they do provide a picture for me. All right. So what is the picture over here? Well, I'm going to talk about one thing at a time. Now, this is the problem for a lot of students. Even with the graph given, they don't know what is what. So let's talk about that. I know this thing from math. From math. I'm going to say 100, 119, and 120. It's a parabola. I know that. All right, let me go to a different color though. I know this is the parabola. Well, looking at the picture, I hope you realize the parabola is this guy over here. Now, you definitely did that in lower level classes, even going back to Math 100. I know that much. The other guy, I'll be honest with you, is more difficult to graph, but I do recognize the graph over there. So let's talk about that. And we're going to talk about this guy right over here. Now, again, a picture is being provided for a reason. You can do this on your computers if you like, or your cell phone, but you should be able to generate these pictures over here. Okay. The other thing you should be able to do is find the points of intersection. The problem with that, though, you're not going to be able to do it by hand. You're going to need to use technology. But I want to claim they give me the points. They gave me the points. This point, this point. You should be able to look at that picture and know that this point here corresponds to that point there. How do I know that? Look at the picture. You see it's 2 point something, 1 point something. You should be able to look at the picture and determine it's this point over here. So what did I do now? I visualized the two curves and their points of intersection, and then I'm going to shade in the region that's enclosed. All right, now what's enclosed? Where it's bounded. Let's shade that in for you. I'm going to say it's shaded in over here. A coloring book. Here comes my problem, setting up the integral. That's going to be the difficult problem for a lot of students, just setting up the integration in the problem. So I want to point out there's a couple of ways of doing it. Now, as I do that over here, I want to point out I could draw my rectangles this way. If I did that, the differential would be dx. If I do this, rectangle this way, the differential would be dy. So what I want to do is I want to say, I don't know what to do. So I want to write down one at a time, and I'm going to take the one that's easiest for me to do. Let me do the dx first. All right. Now, where do the x's go from? Minus 1.00257. No, I would not expect you to compute with that. We're just writing things down. That's all we're doing. Where does the x stop? 2.19305. Let's say you want to do the dy's instead. By the way, we still need this, which is called the integrand. I'm just going to talk about the y's now. Where does the y start? Minus 0.30349. These numbers have been given to me, and it stops at 1.26137. Here comes my problem, getting the integrand. I want to point out the integrand over here must be in terms of y. This integrand over here must be in terms, I'm sorry about that, put that down, terms of x. Let's take a look at these guys over here. And what I'm going to claim over here is that I'm going to claim this guy here is solved for x. However, you could also solve for y, but that to me sounds like a tough thing to do. But you could solve this thing for y. But I don't want to do that because it's too much work. It's a quadratic formula. I'm looking at this thing over here. This thing is solved for y. Well, one solved for x, one solved for y. Which one is easier to solve for the other letter, though? I'm going to say this one over here is going to be really easy to solve for x. So what do you get? Let's put that down. Y to the 5th power equals x plus 1, right? And then what's x equal to? X would equal y5 minus 1. All right, let's go back to the graph. And I'm starting to think I'm going to be doing the dy's. And why is that? I know what x upper is and x lower is. Let's talk about x upper here. Upper. X upper. Which of those two curves is the upper curve? It's the quadratic. So x upper is equal to 3y minus y squared. All right, let's look at the lower part. This is the lower. This is x lower. What's the lower part? It's that, that fifth degree root problem. So what do I get? I'm going to write the x lower is actually x equals y5 minus 1. So I'm going to claim over here I'm going to use the dy in the problem. This one's too much work, too much work. Could it be done? Yes, but to me, it's too much work. Here's what we're going to do. I'm going to write down, what's the upper? 3y minus y squared minus the lower. What's the lower? y5 minus 1. Okay, I know this is difficult, but I want to go through the steps now. Minus 0.30349, 1.26, 137. Yeah, I copied. They're shorter than your phone numbers, by the way. What do you get over here? 3y minus y squared minus y5 plus 1 dy. I'm not going to do any arithmetic that's beyond what I call a moderate skill set. 3y squared over 2 minus y cubed over 3 minus y6 over 6 plus y. I have to evaluate it at the limits of integration. So minus 30349. And the upper limit is 126, 137. I'm not going to do that though. Here's the deal. If you can get to that stage, you've done a really good job. All right. So someone can say, well, how would you have done it? I would have used technology, but I want to point out, I did write this down. All right. What I mean by that, I'm going to copy that for you. Let me just go backwards. And I'll copy this. Give me 1 second. Sorry about that. I'll paste it over here. Just give me a second to paste it in. And I want to pull up, this is an exam question. It would be set up the integration. You don't have to do the integration though. Let's see how we did. Did I get the limits right? I did. Did I get the integrand right? Wow. I didn't get this though. Let's talk about that. Before I do that though, I want to make sure I covered out everything I need to cover out. And we did that page. And let me see if I did this page completely. Yeah, I did. We'll do examples next, but I want to go to technology and I'll be brief about it. And what do you mean by brief about it? I'll be brief. So what I'm going to do here is do another share with you. Give me a second. I'm going to open up my Sage. I'm going to run Sage for you. Oh, I'm sorry. That's not Sage. That's my top application. Let me quit that. I'm going to run Sage. I'm also going to run Grapher. And again, I'm not telling you what applications to use. And that's good. I mean, when you transfer to NJIT, they're going to really be nasty about it. They're going to say, by the way, every school is, by the way, oh, you have to use this software or that software. When you work for an employer, they really mandate what software you can be using. I'd say the more tools you have, the better. And the tools that you're comfortable using, that's what you want to do. All right. So someone says, what are you going to do over here? I want to point out, I want to graph something. And someone says, what are you going to graph? I'm going to graph these two functions out. And what's the first one? Well, it looks like x plus 1 to the 5th power. And that's going to be 1 divided by 5. All right, put that down. I got that graph done. That does really quickly, quicker than I could do it. And what's the other graph going to be? I'll put that down for you. New equation. And that graph's going to be y, x equals now, not y equals. X equals 3y minus y squared. All right, so I see that. What I'm going to do is I'm going to zoom into that region. So let me do that for you. And I'm going to say this is the kind of the region I'm interested in over here. I'm going to zoom into that. And what I like to do is I like to do the points of intersection. So let me do this over here. And I'm looking at it. I'm going to say the point of intersection appears to be about 2. Let me just, and again, I'm using software. I'm not doing this by anything but software. So let me show you this over here. So what I'm going to do over here, let's see. I'm going to find intersection. It asked me a couple to guess. I'm going to say 2. What does it give me? It gives me those numbers over there. I want to just emphasize that these numbers are in your notes. Let me pull this on the side for you. And let me go to the next page. Where did I put that down for you? Oh, right over here. So what are the numbers going to be? 2.9, 3. Well, they rounded off to that place. That's fine. The other one is 1.261. Yeah, that looks pretty good. What was the other place I thought it intersect? At about -1. Let's see how it does. What do I get? Well, that's a weird one. You know what? I'm going to do something over here. -0.9. You know what? I think I made a mistake here. Let me go back over that again. Let me just select both of these. Point of intersection. I'm looking at it, by the way. So I'm wondering why the software is having a tough time with that. And I'm going to say X is about -1.1. It's not coming up with it. All right, I want to just zoom out a little bit, find out what it's doing. It's actually coming up at this point over here. It's having a really tough time with this point over here. So what I'm going to do is I'm going to try something else. I'm going to try to use Sage for it because I know my software here, Grapher, is having a tough time with this one. It found this one, it found this one, but it's having a really tough time with this one. So what I want to do is I want to go to Sage. All right, I go to Sage. And again, we're trying to teach resiliency. If something doesn't work, try another tool. Let's put that down. We're going to go to Sage now. And I'm going to use find root. All right, find root. And I'm going to find root of, let's see if I can do it. And this, maybe Sage can have tough time with it too. Then maybe I have to go to Newton's method, which I hope I don't have to. X plus 1. We also have alpha at our disposal to the 5th power. You know what I got to do? I got to solve that. And I'm going to say, you remember that was y to the 5th minus 1 equals x. Let me reset. Give me 1 second. I'm going to let y be a variable. Whoops. Again, resiliency is really important. I'm going to get a will from alpha 2, by the way, because I realize this is tough for some students to use. So what are we going to do? We're going to find root. Oops, didn't mean to do that. And I can find the root of, let's see, it's going to be x equals y to the 5th minus 1. And then we're going to do minus 3y. I'm just basically going to solve an equation for its root plus y squared. And we're going to solve for y. And I'm sorry, no, I think I got to do the interval. So I'm going to say between minus 1.1 and minus, let me do minus 1.3 and 0. Let's see if I put it in. You know what? I did wrong syntax over here. So what I'm going to do is I'll show you something. I'm going to do find root. And I'll put a question mark there. It'll tell me how to use the command. So let's take a look at that. And I'm looking at an example over here. And gee, I thought I was using it right. Let me just do that again. Y the 5th. Oh, I see it now. You know what I didn't do? Star Y. It gave me the number. Someone said, what number did it give me? It gave me this number over here, the Y value. All right. I'm also going to go to Wolfram Alpha. And as I do Wolfram Alpha, I want to point out that you're free to use the software that you like using. All right. Let me go to Wolfram Alpha. And Wolfram Alpha is not a bad software. The problem with Wolfram Alpha, it's commercial. And commercial software, they're trying to sell you something. All right. So I'm going to say solve. I'm going to say y equals x plus 1 to the 5th power. I have no idea what it's going to do, by the way. To the 1/5 power, I'm sorry. And x equals 3y. Much easier to use in Sage, by the way. Put it in there. I don't know what it's going to do. Let's see what happens. Well, let me take a look. It does pretty good. It gives me the 2.19305, 126.327. Gave me that one. You know what it didn't do? It didn't do the other one. I want to point out, this is another issue. The other issue is it's looking at the 5th root, and for some reason, it's not going below the 0. All right, it's not going below the 0. But you get the idea. Well, how many software packs I use? I use Grapher. It had a tough time finding that smaller one. And then what I do, I had to go to Sage. Sage was able to do it. And then I went to Wolfram Alpha, and Wolfram Alpha trouble with it. It's going to happen to you. All right. So what am I going to do now? I'm going to say I did get the points of intersection. I did use Sage to help me out with that. All right. I use Sage to help out with that. Now, what I want to do is I want to do the integration. Let me clear the screen, CLEAR. And what I'm going to do, I want to do the integration. And someone says, well, why do you want to do the integration? Just to see how the computer does it. So integrate. I use tab completion, by the way. I'm sorry. I don't want integral closure, integrate. Sorry about that. And what am I integrating? Let's write this down. 3 star y minus y squared. I'm just copying what I see on my notes, by the way. Minus y to the 5 plus 1. We're integrating with respect to y, and the y's are starting at, let's take a look, minus 0.30349, comma, whoops, that's a period, that's not a comma. And then we get 1.26137. Hope I typed that in right. When you get over here, you get the number they got, which is 2.4638. And again, they give more digits, by the way. You get the idea, though. Computers are important. It really is important, all right, that you start to learn how to use a computer. Computers can be frustrating, though. You're using one application, doesn't work so well, another one, maybe that works better. You need options, though, not just one option. You're going to find out when you transfer NJIT and they're forcing you to use MATLAB, there may be better applications out there for particular purposes. The more tools you have at your disposal, the better it's going to be for you. Thank you.